So as I mentioned last class, we're going to do a lot of graphing this year, and a lot of the expressions that we graph or equations that we graph are called functions. And you guys learned about what functions were actually in grade 10. Okay, and we still did it in grade 11, but we did quadratic functions. Those were the parabolas. And we also did some other functions, absolute value and rational functions. So I just want to review a few things about functions in this first lesson. And then we'll go on to how to graph them and how to graph transformations of them. Like what happens if we have a graph of a function and we do some stuff to it. We move it around the graph, or we flip it over some lines, or we stretch it horizontally, or we stretch it vertically. How do we do that kind of stuff? That's really the focus of the first unit. But for the time being, way back in grade 10, we talked about relations. And a relation is a rule that associates one set of information with another. So like if and it's usually, we're going to deal with numbers, but it doesn't have to be numbers. Like, what if I said this? Don't write this down. But here I'm going to write down here's a first set of information. Here's a second set. Here's a first set of information. Here's a second set. Here's a first set of information. Here's the second set. Can you tell me the rule? Do you think you can tell me the rule?
When there's like 3 letters, like a word.
Nope. Oh, good try. What's that? The amount of legs. So it's a rule that associates an animal with how many legs they have. Okay? So this is the first set of information, happens to be words, happens to be animals. This is the second set of information, happens to be numbers. Okay? So there's a relation between those two. And there's different ways we can show relations. And we talked about this way back in grade 10. We could show it as a set of ordered pairs. So like if I showed a relation that looked like this, the ordered pair 1, -2. And then another ordered pair in this relation, 5, -10. And we'll just keep it a really simple relation. We'll only have 3 ordered pairs in here. 7, -14. Can you see the rule? What are you doing? Multiplying by -2. Okay? We could show a relation as an equation. So in that previous example, I could say to get the second set of information, which we call y, or we give another name that you guys are familiar with, I'll talk about in a second. You take the first set of information called x and you times it by -2. So that would be converting this into an equation. But equations can look, they could have squareds in them. We're going to see this year they can have cubes in them. They can have fourth exponents in them. Okay? Doesn't necessarily have to be y equals. It could be x plus y equals 1. That's still an equation that shows a relation. Okay? First set of information we usually call the x's. Second set of information we usually call the y's.
Well, we could describe it in words. Output is -2 times input.
That could describe the relation that I showed you in the ordered pairs.
We haven't seen this for a couple of years, something called an arrow diagram. Where you put all the X's, all the first pieces of information into one oval. And you put all the second pieces of information into a second oval. And you use arrows to connect the pairs that go together. So it would look like this. Okay. You graph it.
We're showing a relationship between two variables. Well, that's what a coordinate grid does.
It shows the relationship between X.
Values and Y values. And we looked at all sorts of graphs already.
Okay. Last year we looked at these. Grade 10, we looked at these.
And those aren't the only ones we've looked at, but there's just a couple of examples. And finally,
A lot of times the graphic, we need table values. So that's taking all the ordered pairs and putting them into a table beside each other. So what did I have? 1, -2, 5, -10, 7, -14.
And that's showing the relation using a table. We're not going to worry about arrow diagrams, okay? We're not really going to worry about words. We're going to focus on graphs, table of values, and equations. And we're not going to do much with ordered pairs, okay? Now, there was a special type of relation that we called a function, okay?
A function, and this is what we started in grade 10, we continued to study last year, is every input for X value has one corresponding output. For Y value.
Or another way that I always phrased it, and we use a different name besides X values,
The X values never repeat. They can never happen more than once.
if they happen more than once, it's not a function. Is this a function? Do all the X values happen once, or do some of them repeat? They happen once. There's a 1, a 5, a 7.
If I had something like, so this is a function. But if I had something like this, 1, -2, 1, -3, 5, -10, that is not a function. Because the 1 repeats. The 1 does not exactly have one corresponding Y, it's got 2. Okay? So that's not a function.
A lot of times we use graphs. How can we tell if a graph is a function or not?
We did this thing called the vertical line test. And what does that mean? If you can draw a vertical line through more than one point. On a graph, it is not a function.
Okay? If you can't, it is. So that's a really quick way to tell a function, or a graph of a, they're all called relations, but only some of them are called functions.
So if I look at these two examples,
If I look at A, there's the graph.
it's a parabola.
Okay, that you guys are used to seeing. Can I draw a vertical line through more than one point?
No. If I try drawing a vertical line here, I only get one. If I try drawing a vertical line here, I only get one. There's nowhere on the graph I could draw a vertical line and hit two or more. So, function, it's good.
How about this one? Not a function. There's a whole bunch of vertical lines I could draw and hit more than one point.
I could draw a vertical line here. I hit the graph here and here.
As soon as it happens once,
Not a function.
okay? Something to keep in mind. Do you remember the two names we gave to all the x values in relation or functions and all the y values in relations or functions? Do you remember the two names we gave them? Domain and range.
So, domain, all the x values or first values in a relation whereas the range would be all the y values. Or the second values. And what I mean by that, well, I'm going to finish this in relation. So if they're listed as ordered pairs, all the first values in the parentheses are the domain. All the second values are the range.
If it's listed as a table, all the values in the first column are the domain. All the values in the second column are the range. Okay?
We learned a couple of different ways to write domain and range.
One was called interval notation and another was called set notation, that it used inequality signs like greater than or less than, or greater than or equal to or less than or equal to. We usually focused on interval because it was generally easier.
What else do we remember? Can somebody tell me the domain of this graph?
What are all the x values are represented on this graph, this line that has a starting point?
Okay, so one way is you can say, remember, domain is x. They're all greater than or equal to
-2. That's set notation.
Who remembers interval? -2 to infinity.
With the parenthesis, yes. When we use interval notation, let's see, you look at your graph and you say, okay, where's the furthest point to the left? Well, it's here. What's its x value? -2. So that's my starting point. Bracket means I include -2 because there's a filled in circle there.
And then I say, okay, what's the furthest right value? Well, this thing goes on up forever and to the right forever. Whoa. What the- Right. So that means it goes on forever. And what symbol do we use forever? Infinity. If it goes to the right forever. If it goes to the left forever, it's negative. The range, lowest y to highest y. Well, where's the lowest point on the graph? Here. What's its y value? So that's my, am I included? I'm doing interval notation right now. What's the highest value? Well, this tells me it goes up forever. And the highest value is infinity. Or if we were to write it, remember domain is y, everything greater than or equal to -3. You don't have to write both. Only write one of them. Whatever one you're comfortable with. For most of you that were with me last year, I'm assuming it'll probably be interval. That's okay. If you write it in set notation, like using these, that's fine too. But don't feel like, and I know because some students still do this, don't feel like you have to write both. You don't. Just one. How about this one?
1, 5.
Okay,
We need 1.
okay. So tell me what's right.
Square
Bracket,
1.
Yep.
Same bracket.
right? See that?
Here's where interval notation is really good.
Furthest left point is here, the x value is 1. Furthest right point is 5. Because there is a curve connecting, it's everything in between.
So everything starting at 1 up to and including 5.
If you wrote this in the other way, it's a little bit more complicated. It would look like this. Because this means x is between 1 and 5.
We use the less than or equal to symbols always. Okay.
How about the range? Now you got to change your thinking. Lowest y to highest y. -2. And because there's a curve connecting all the way up to positive. Or you write it using interval notation, it would look like that.
Remember, functions and relations can be shown as equations, like C is. Well, think about what this would look like on a graph. What kind of shape would it take? It's a really easy question that you guys always overthink. It's a line. If it doesn't have a square in it, it's just a line.
So it's going to look something like this.
Doesn't a line go on forever in every direction? Like it goes to the left forever, to the right forever, down forever, up forever.
So that means that the domain is every single number, starting from the lowest negative infinity up to the highest positive infinity. And the range is the exact same thing.
Lines are really easy to find the domain and range of. It's everything.
Okay, continuing a little bit of review. I'm going to finish off with this.
We use special notation when we talked about functions.
Okay. Where we use letters,
And then we usually had an X in parentheses. Remember how to read this? It's the same as Y, or if you actually read this, F of X, right?
G of x, h of x. And you're right, it means the exact same thing as y. All this means is that it's a relation. This means because this is a line, it's also a function. That's all that means. But we can treat these two as equivalent. How would you find f of 3? What's the 3 replacing?
Yes.
The x. So replace the x on the right side. You get 3 plus 2. What's f of 0? It's 2. Because you replace the x with 0, add 2, and you get 2. G of 2. Well, every time you see an x, replace it with 2. And you get 9 over 2. Which you don't have to change. Don't change it to decimal. Don't change it to a mixed number. Leave it as a fraction. G of 0. Well, replace every x with 0, and I get 4 times 0 plus 1 divides 0.
Undefined, you cannot divide by 0. Undefined.
H of -5. Well, that means we got to go to function h, and every time we see an x, we replace it with -5. Well, there's only one time that we see an x, so we get that.
And you just got to remember your order of operations.
And squaring negative numbers.
Sorry? 122? Well,
25.
so you say an answer and then you say, I don't know.
72.
Thank you.
-5 squared is 25. 25 times 3 is 75. 75 minus 3 is 72.
Sometimes you may not be asked to replace a letter with a number, but with another letter.
That's okay. Don't let it throw you. All this means is replace the x with a.
I don't know what A is, so I can't go any further. Can I make this simpler? Can I combine the two and make it 2A? Oh, no. No, you can't.
It would have to be a plus a. Here, well, I take the x and replace it with m plus 1. So it looks like this.
This I can do some simplifying to.
Actually, a fair bit. Remember, m plus 1 squared means take m plus 1 all together, parentheses and all, and multiply it by itself. So now I got to multiply these three things together. You can't multiply them all together at the same time. You got to multiply 2 of them and then take that answer and multiply it by the third. So it doesn't matter what order I multiply, so I'm going to do these two first. What is n plus 1 times m plus 1? M squared plus m plus another m plus 1. Close those parentheses because I still got to take this and multiply everything here by 3. So I get 3m squared plus 3m plus 3m plus 3, and there's still a minus 3. Well, those go. 3 and minus 3 cancel each other out, and I'm left with 3m squared plus 6m. You really don't need to worry about one like this. Okay? But you should be familiar with how to multiply these. Okay? But I just kind of threw that in there just to sort of try and refresh your memory on multiplying the variables. So all of these were equations. All the functions you were given were in equation form. F of x, g of x, and h of x. They may not be in equation form. Remember at the beginning I said they could be a set of ordered pairs. So here's a function f of x that has 4 ordered pairs in it. Here's a function called h of x where all it says is in words. The output is twice the input. Here's a function f of x that kind of looks like an equation. It's just 4. Here's one that in graph form. Here's one in table of values. So go to the function according to the letter and find the answer. So f of 0, that means I got to go here. Remember, this represents x, right? Where do you see x as 0? When y is 3. Right? You see x is 0 here. Well, what's the y that goes with the 0? 3. That's your answer. What's f of negative 8? Do you see a negative 8 for x? No, that means there's no answer to this. Or we can say undefined, or you can just say there's no answer because there's nowhere in these points, these coordinate pairs, where x is negative 8, so I can't answer it. P of 5. Well, go to function P. Find where x is 5, find its corresponding y. Where x is 5. Remember, these are the x's. Right. So what's the y? Oh, I thought I heard somebody say negative 3. All right, all right, all right. G of negative 1. Well, you got to go to the graph and find the point on the graph, on the V-shaped, where x is negative 1. Well, here's negative 1, so I'm just going to go up to the graph right here. This is where x is negative 1. What's the y? That's the answer. M of negative 100. Don't overthink. It's 4. It doesn't matter what this is because there's no x to plug in here. The answer is always just 4. Nothing to plug in for x. Finally, h of negative 15. Well, input means x, right? So if I input negative 15, what does it tell me to get to the output? Double it. So I get negative 30.
So all of these, you were given X, and you just used the appropriate function to find its corresponding Y value. Sometimes you may be asked to work backwards. Here, we're not told X is 2. We're told that G of X is 2. That means the same thing as Y is 2. So if Y is 2, what are the corresponding value or values of X? Where do we see on this graph where Y is 2? Here, when X is 4, and here, when X is 0. So there's actually 2 X's here. Four and 0. Notice you're asked to work backwards. Okay? That's basically functions in a nutshell. Okay? Big thing you need to know from this, from the review, is what's a function, what isn't, and how to do some calculations using function notation, especially the equations. Not so much this stuff that we did, but I wanted to show you that we can answer questions if the function is in a graph form, or is in table of values form, or is in ordered pairs form. Okay? And the other big thing is knowing domain and range. That's a big one too. Okay. So for what did I say? I think I said, no, it can't be for Thursday because we don't have class Thursday. When do you want to make this due? I'm going to do 1.2 tomorrow. Friday?
Yeah.
Wednesday? All right. So exercise 1.1 for Friday. So we'll take Friday and go over any questions from exercise 1.1 and 1.2. Where am I here? Here we go.